Alright, so this is back to Algebra 2. We are finishing up the 5.6 notes. This is going to be kind of like 5.6 part 3, the last part here. And really, the only thing left we need to do is learning kind of how to multiply kind of complex numbers and multiply not these root numbers. And then after this, we'll kind of start off with some 5.7. Probably start the first part of that. So we're starting off by we're basically simplifying out these numbers here. We have square root of 7 times square root of 3, and then multiply by in this whole parenthesis 3 root 5, and then plus square root of 2. And just as we would do if we were multiplying polynomials or binomials, all we do with this number right here is we not only multiply it to this one, we do to this one. We distribute. Okay, and we're just going to distribute it out. So we're going to get 7. I'm just going to kind of write them out here. 7 root 3 times 3 root 5 plus, again, 7 root 3 times root 2. All right, and then from there we multiply them together. Now when we multiply these together, we actually do multiply the two numbers inside with the numbers outside as well. There's a big difference. When we're multiplying, that was when we can combine these, but when we're adding them, we can't combine them. All right. So we go ahead and do that. We do this. Let's do the numbers out front. 7 times 3, we're just going to get 21 outside. And then the square root of 3 times the square root of 5. Again, when you're multiplying radicals, all you do is you multiply the numbers inside. 3 times 5, that just gets you 15. So we turn it into 21 times the square root of 15. And then over here we have the 7 times the square root of 3 times the square root of 2. Technically there is a number 1 out there. Sorry for my bad handwriting. 7 times 1, that just gives me 7. Times square root of 3 times the square root of 2, that just gives me the square root of 6. And then from here we would say, hey, are there any numbers that we can simplify down? Can we simplify down 15 or the square root of 6? We cannot. So that is our final answer, simplified answer right there. Going on to example 2 right here, all right? Just as we would do, say, if we were multiplying, x minus 3 times, x plus 4, we distribute this term out to all these terms right here. We distribute this term to all these terms right here. It's the same idea right here. We're going to distribute this Going to distribute the 2 to the 7 and the 2 to the negative square root of 6. And then we're going to distribute the square root of 5 to the 7 and to the square root of negative square root of 6. So let's go ahead and do that. So I'm going to do 2 distributed to the 7. That's just going to give me 2 times 7. And then I got 2. And then this one, right? So I'm going to do kind of write these down in steps. So then 2 times the negative square root of 6. And then over here, I got the square root of 5 times 7, and then the square root of 5 times the negative square root of 6. And I'm going to just kind of simplify all these out kind of in steps here. 2 times 7, that's just going to give me 14. 2 times negative square root of 6, that's just going to get me negative 2 square root of 6. Again, I don't multiply these two numbers together because one is underneath the radical sign and one is not. All I do is just put the negative out front there. So I'm going to get negative 2 times the square root of 6. Same with right here. I got a 7 that's not underneath the radical and a 5 that is. That just turns into 7 times the square root of 5. And then right here, I got the square root of 5 times the negative square root of 6. We combine those together. These two numbers are underneath the radical symbol, so I'm going to combine those to get negative square root of 30. All right. And then if we combine them all together, we're going to get 14 from what I got here minus 2 times the square root of 6 plus, because that's a positive 7, plus 7 times the square root of 5 minus the square root of 30. And then from there, we would see, can we simplify any of these out? Are there any perfect squares that go into 6 or 5 or 30 that we can divide any of these by? And to be quite honest with you, there really aren't. 4, again, it's 4, 9, 16, 25. Again, these are really the only numbers we can work with, and none of these numbers right here can evenly divide out 6, 5, or 30. So that would really be our final answer here, okay? All right, so now we go on to example number 3, and this is essentially the same thing we're doing up here, but we're going on with imaginary numbers. Now, we're starting off with 2i plus 9 squared, and if we were to do that, again, all we really would do is, again, we wouldn't distribute the squared out here. Again, that is something we don't do. All right, do not do that. All right, that's something I see way too many times. We can't distribute out that squared. What we need to do is we need to expand this out as 2i plus 9 times 2i plus 9. And then from there, just as we did up here with example 2, we're just going to distribute out our terms to each other and multiply out. 2i times 2i is going to get me 4i squared. And then 2i plus 9 is going to get me just 18i. Again, I just multiply the 9 and the 2 outside there to get me 18. 9 times 2 is going to get me another 18i. And then 9 plus 9, that's just 9 squared, which is 81, okay? But from there, we also have to remember our rule that I squared is equal to a negative 1. So wherever I have an I squared at, I am going to substitute in just multiplying that, whatever that number is, times a negative 1. So instead of the 4i squared, I'm going to put in 4 times a negative 1, which, if we multiply that together, is just simply a negative 4. And then from there, we, just go about combining our like terms. We do negative 4. Oh. There we go. Negative 4 and the 81 together, that's going to get me a positive 77. So I'm just going to write a plus 77. And then 18i plus 18i, we combine these two together to get me a 36i. All right? Just combining those together right there. And then this last example right here, just kind of going through that. I'm going to write this I squared is equal to negative 1. Just write it right here just so that we know about it. Again, we're just going to combine. We're just going to multiply, distribute out, multiply, combine our terms. So 3 times 5, that's going to get me a 15. 3 times a negative 2i, that's going to get me a negative 6i. I multiply this out, 8 times 5, that's going to give me a positive 40i, and then 8 times a negative 2i is going to give me a negative 16i squared. However, again, I see this I squared, I'm going to substitute in multiplying that number by just a negative 1, because again, I squared is equal to negative 1. And then from there, negative 16 times a negative 1, that's going to get me a positive 16 for right there. And then from there, we combine our like terms. 15 plus 16, that's going to get me a 31. Negative 6i plus 40i, that's going to get me a 34i. And then it's plus 31. And that is my final simplified answer right there. Okay? Alrighty, so that is kind of the end of 5.6. Again, that's just kind of the end of multiplying, distributing, multiplying kind of different complex numbers and all that kind of stuff. From there, we're going to go into another, just go ahead and discard that. We're going to go into another, just kind of the start of 5.7, part 1, which deals with solving radical equations. So it's essentially equations that have radicals inside of them, and we need to, solve them. All right, so this is part 1, sorry. And when solving radical equations, this is something that you should have seen in Algebra 1. However, that was also during the COVID year, so this also may have been lost on some of you guys. But solving radical equations, it's a lot like solving our regular equations. We want to isolate the radical. Anytime we isolate the radical, we're talking about whatever this is, what's underneath the radical. We want to basically get all the stuff that's on the outside of the radical moved off of the radical. And then we raise each side to the root number in order to get rid of the root. And then we solve for the variable, and then we need to check for our extraneous solutions on the end here, all right? All right, so now we check, solve for example 1 right here. So we want to isolate the radical. We want to look, are there any numbers, basically what I would say, circle your radical. Are there any numbers that are outside of the radical that we need to get rid of? And if we look, we have this 9 right here, so I need to add 9 to both sides, all right? Because again, minus 9, we just add it to both sides to get rid of it. We got the square root of x, negative 1 plus 9, that just gives me an 8. And then from there, we raise each side to the root number. So we're going to take each of these sides to a power. Now, remember now it's whatever root number we have, but in this instance, we have a square root. Remember that the square root is the same as having a root number of 2. So because of that, we're going to raise each of these sides to the second power, okay? We're going to raise each of these sides to the second power in order to solve, and then from there, raising this to the second power is going to cancel out the square roots, which just leaves me with x. And then I'm going to be left with e equal to 8 squared. 8 squared is equal to 60. X is equal to 64. But we need to go back in and check to make sure that that number, that power, or that answer works for our equation. So I'm going to go back and check. Square root of 64 minus 9 is equal to negative 1. Square root of 64, again, is equal to the square root of 8 minus 9, which is equal to negative 1. That works out, so we are good in our solution there. Because, again, there's going to be times where we have extraneous solutions, which basically tells us that we get a solution, x is equal to a number that works, but if we actually dig deeper and check it out, we'd find out that for some reason, we're not going to get ourselves, that answer just doesn't check out for some reason, and we'll kind of see some examples of that. So let's go ahead and do example number 2 here. We have the cube root of 2x plus 7. And again, what I like to do is I circle my root, my radical, and do I have any numbers outside that I need to get rid of? Do I have any numbers like multiplying outside that I need to get rid of? Do I have any numbers adding or dividing that I need to get rid of? I see that I don't, so what I'm going to do is I'm going to raise both sides of these equal signs to whatever the root number is. So I'm going to raise each of these sides to the third power. So I'm going to do third root. I'm going to basically do the third root of 2x plus 7 to the third power. And then I'm going to raise 3 to the third power. And then again, if you raise these to each power, these roots, these cancel out, the root cancels out. You are left with whatever is underneath the radical. That does not change. It is 2x plus 7 underneath. All you do, when you cube both sides, you get rid of the radical. You're left with what is underneath, 2x plus 7. Equals 3 to the third power, which is basically equal to 27. And then from there, we solve for x. Minus 7 on both sides. 2x is equal to, 27 minus 7 is equal to 20. We solve for x. We're going to see that x is equal to 10. And then from there, we need to go back in, plug this answer back in to make sure that our answer is correct. So I'm going to do the cube root of 2x, which is 10. So I'm going to plug in 10 plus 7. 2 times 10 is equal to 20 plus 7, cube root of that. And again, this has to be equal to 3. And we get the cube root of 27, which is indeed equal to 3. So our answer down here does check out and is not extraneous. All right, so now we have another example here. We have example 3 in which we have our fourth root here. We have the fourth root of x minus 3. I'm going to circle just the root, not the numbers outside. And I see that I have a couple numbers outside that I need to get rid of. Again, I need to isolate this radical. So what I'm going to do, I'm going to subtract the 7 on both sides. I'm going to get 13 minus 7 is equal to 6. Fourth root of x minus 3, and then 2. I have the 2 that is being multiplied by the fourth root of x minus 3, so I'm going to divide by 2 on both sides. And I'm going to get the fourth root of x minus 3 is equal to 3. And then from there, again, now we have had our radical all isolated, all right? It is all by itself. There are no numbers that are outside that are multiplying, dividing, adding, or subtracting to it. So from there, I can now raise both sides to whatever power we have here. So I'm going to raise it to the fourth power, and then the fourth power cancels out the radicals here. I am left with whatever's underneath the radical, which is x minus 3. And then 3 to the fourth power is just equal to 81. I'm going to add the 3 over, and then I'm going to get x is equal to 84. And I have to stop it right there. I can't check for extraneous solutions.